Bismillah ar-Rahman ar-Rahim. Hello everybody. This is a new video about functions. Today we are concerned by the monotonicity of functions, which means that are the functions increasing, decreasing, non-increasing or non-decreasing. We have two ways actually, at least we have two ways to deal with this question. If the function is smooth enough, we have a way. If the function isn't smooth at all, so we have to wait. What we mean by smooth enough? We mean differentiable. This is way is differentiable This means it admits a derivative. I will deal with this question by the different method. For this one and this one, we will use this method. Despite that it is smooth, but I will use the different method. This one isn't smooth enough, but this one it is smooth. Despite this, we will use for this and this technique, and for this function and this function this technique. Let us get started. For F1, we have to study the monotonicity on this domain, 0 plus infinity. Let x and y belongs to E such that x is less than y. X is greater than 0. This implies that 1 divided by y is less than y divided by x, which means if we add 1 to both inequality, we get 1 plus 1 divided by y strictly less than 1 plus 1 divided by x, but this is actually f1 of y and this is f1 of x. This means that this function is a decreasing one, and not non-increasing. It is decreasing, which means strictly decreasing. There is a little bit difference between French and English definitions. F1 is a decreasing one. How about F2? F2 is smooth enough, so we calculate the derivative of F2 prime of x. This is equal to the derivative of the numerator, so exponential x plus exponential minus x, times the denominator, so square, minus the derivative of the denominator, which means exponential x minus x, times the numerator square, divided by exponential x plus exponential minus x square. And this is equal to, here we will get, so we will lose this one with this one. So let us do it slowly. Exponential 2x plus exponential minus 2x plus 2 minus exponential 2x plus exponential minus x minus 2x, sorry, minus 2 divided by square. Here we lost this one with this one and this one with this one, so we keep 4. We get 4 divided by square, which is strictly greater than 0. This means that f2 is increasing. It is increasing. We mean in French strictement croissant. متزايدة تماما. In Arabic. How about cosine x? How about cosine x? The same technique. It is smooth enough. So f3 prime of x, this is equal to minus sine x, and this is greater than 0 or equal on e equal to 0 pi. This means that if we take off this domain like this, it will be strictly greater than 0. So f3 is sine x is positive minus, so sorry, it is less than 0. So f3 is sine x is positive on 0 pi times minus, it will be negative. So f3 is decreasing. It is decreasing on 0 pi. If we take 0 and pi in the interval, it will be non-increasing. It will be non-increasing on 0 and pi. How about the last one, f4? We will use the technique for non-smooth functions, which means that we have to compare different value of f4. The domain of definition, since we are dealing with the integer part of real numbers, so we can write the domain of definition on which we are supposed to study the monotonicity of this function. We take this domain, which is equal to 1 plus infinity, and we write it like the union on k plus 1. K start from 1 to infinity. And we discuss cases. The first case, if x and y belongs to the same subinterval, such that x is less than equal, for example. In this case, if there exists k from n, such that we have this case. This is the first case. In this case, what we have? We have the integer part of x is equal to an integer part of y and is equal to k. So we get k times for x, k times x plus k power k, which is less than k times y plus k power k. This means this is f4 of x, which is less than f4 of y. If x and y belongs to the same subinterval, we get this, which means that it is increasing. The second case, The second case, this means that x belongs to k plus 1, and y belongs to k prime plus 1, such that, for example, if we take x less than y, such that k is strictly less than k prime. They exist in different sub-intervals, which are far from to each other. They are far. They are not in the same sub-interval. So if they are in the same sub-interval, it is increasing. If they are far, what we will get? We will get k here, x and k power. Here we get k prime. And in this case, it is obvious that it is strictly less than, which means that in both cases they are the function is increasing. This finished this video. Thank you very much. The next one will be about I think periodicity and parity, which means even or odd function. To this time, see you next time, inshallah.